Hello student, I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss some numericals based on effect of temperature on rate of reaction. Last class I have discussed effect of temperature. Question first I will read, then I will explain the solution. Question now I am reading the rate constants of a reaction at 500 Kelvin and 700 Kelvin are 0.02 per second and 0.07 per second respectively. Calculate the values of EA and A. EA means activation energy and A, that is the frequency factor. Then this data has been given, that is K1 and K2 value is given and temperature is given, means at 500 Kelvin K1 value is 0.0 per second and at 700 Kelvin K2 value is 0.02 is for K1 and 0.07 per second is for K2. You have to calculate two things, activation energy and constant. Okay, frequency factor A, capital A. Then it is very easy to calculate. If you are remembering expression, means relation between K and K activation energy and temperature, then easily you can calculate the EA value and A, capital A, frequency factor. Because all values are given, then what is the formula? You have to remember the formula. Then now I am telling you formula. Log K2 upon K1, that is equal to EA divided by 2.303 R, and you know the this things in bracket 1 upon T1 minus 1 upon T2, or one more this relation is there, easy relation. After simplification of 1 upon T1 minus 1 upon T2 in bracket, you can also write T2 minus T1 divided by T1 into T2. Anyway, this formula can be used. Then here now K2 formula, K2 value is given, K1 value is given, EA value is given, R value you know, T1 and T2 value is given. Then no problem in solving these numericals. Hence, after putting all values, means log K2 is equal to is given 0.07 divided by 0.02, that is the K1 value. After that EA you have to calculate, divided by 2.303 into R. R is equal to 8.314 joule per Kelvin per mole, and in bracket T2 minus T1 divided by T1 into T2. Then now both value you know, T2 value is 700 and T1 value is 500. Then it means 700 minus 500 divided by 700 into 500. Then after solving you will get, means log 0.07 divided by 0.02, its value will come 0.544. That is equal to, now this all things you can calculate. EA you have to calculate, then EA you leave it, down is you have to down you multiply both 2.303 into 8.314, correct. This and after that 700 minus 500 200 divided by 700 into 500, means after solving all the things you will get EA value, means energy of activation, that is you will get 0.544 into 19.15 divided by 5.714 5.714 into 10 to the power minus 4, means you have not done any, just simply you have multiplied that, simplified all the things. Then EA value you will get after simplifying, after solving, you will get 182.30 182.30. This all things if you will multiply and divide all the things, then final result you will get 182.30.8 joule. 182.30, 3 means 3 and 0, 30. 182.30.8 joule. Then this value you got for EA value, energy of activation. Now you are knowing. Second formula you are going to use to get the value of A, frequency factor you want to calculate, capital A. Then for that second formula you will use. Okay, then what is that? K is equal to A into E exponential, E means exponential, minus EA upon RT. EA upon RT. Then Arrhenius, this is called Arrhenius equation. Then now K value you are knowing, A you have to calculate, EA value you are knowing, R value also you are knowing, T value also you are knowing. Because you are to calculate this A frequency factor, you need EA value, R value, T value, K value. Then all value are knowing. And simply you put the all value. Here temperature you can use 700 K. Okay, any one temperature you can use, either 700 or 500, any one, and that K value you have to use. If in question they have given at 500 K value is 0.02, then you can use that value, or other value is, that is for at 700 K 0.07 per second. Any one value you can use, either at 500 or at 700 K, any one value. If suppose you are using at 500 K, then at 500 K, at 500 Kelvin, K value is 0.02 per second. Then that only here in Arrhenius equation, that value you write for rate constant, that is a K. Then now after putting this value you will get 0.02 is equal to A, capital A, you have to calculate, into E means exponential, minus after that EA you have calculate 182.30.8, and down means RT, then R is equal to 8.314, and T is equal to 500. Then again after solving this, if you will do simplification, then only A you are not knowing, all value you are knowing, and one thing is there, just you have to calculate with precaution E value, because E power minus 182.30.8 divided by 8.314 into 500. Then you have to get the value of this exponential value, e power this value what I told you. Then now all things you are knowing, hence a is equal to, we will get a, you know, now that a will be 0.02 divided by e, means exponential power 18230.8 divided by 8.314 into 500, means just to simplify all the things, then you will get a value frequency factor, and its result will come. Actually, if you will do if you will know the value, this exponential value means minus 18230.8 divided by 8.314 into 500. After solving this, then e value will come, that value will come 0.012. Then now 0.02 divided by 0.012, that is the a value. After again simplification, you will get 1.61. Hence finally a is equal to 1.61. Then this type of numericals can be asked, data may be different, but this formula, these two formula you have to use. Okay, then simple formula is a Arrhenius equation. Only on this equation, on the basis of this equation, actually second equation, that is the log k2 upon k1, that equal to E upon 2.303 R in bracket T2 minus T1 divided by T1 into T2 came only by Arrhenius equation. Okay, that last class I have discussed, derived this equation. Only from this Arrhenius equation you got this formula, which at a different temperature. Now second question, second numericals I am telling you. Okay, this numericals is also, actually numericals is easy. Only thing is that you have to remember the formula. If you are knowing the formula, then easily you can solve the numericals. Hence formula you have to remember, that is the main things. Second question also is easy only. Easy is only when you are knowing the formula. Otherwise there is no question of solving the numericals. Now I am reading the question. Second question, the first order rate constant for the decomposition of ethyl iodide by the reaction is given, that is the C2H5I. C2H5I means ethyl iodide. It is in gaseous form. It gives C2H4 means ethylene. Ethylene is a gas, you know, plus other product is HI, hydrogen iodide. Hydrogen iodide is also gas. All three are in gaseous form. At 600 Kelvin, the first order rate constant value is given at 600 Kelvin is 1.60 into 10 to the power minus 5 per second. For this reaction, means C2H6, C2H5I ethyl iodide decomposition, it is this ethyl iodide decomposes into ethylene and HI. Then for this reaction at 600 Kelvin is 1.60 into 10 to the power minus 5 per second. That is the K value. Its energy of activation is 209 Kelvin kilojoule per mole. That is the EA value is given 209 kilojoule per mole. What you have to calculate? Calculate the rate constant of the reaction at 700 Kelvin. Rate constant you have calculate at 700 Kelvin. Here actually at 600 Kelvin, At 600 Kelvin, K value is given. That is the K1, you can tell it is given. Now we have to calculate K2 at 700 Kelvin. Obviously, if temperature is more, then at that temperature, what is this K value? You have to calculate. Then obviously that will be K2 value. For 600, that is the K1. At 600 value is given, this K value is given, and at 700 you have to calculate, and that will be K2. Then now this again formula, which is same formula, only you have to elaborate. That is a log K2 upon K1, that is equal to EA upon 2.303 R in bracket T2 minus T1 divided by T1 into T2. Same formula is there, but here log K2 upon K1 you can write in the form of log K2 minus log K1 also. You know the log formula. Log x upon y is equal to log x minus log y. Then this log K2 upon K1 you can write in the form of log K2 minus log K1 base 10, that you know. Then same formula you can write in this form also, means log K2 minus log K1 is equal to EA upon 2.303 R and in bracket 1 upon T1 minus 1 upon T2. Okay. Then now all things you are knowing except one things which you want to calculate. K2 value want to calculate, correct? Except K2 value, all values you are knowing. K1 value is given, EA value is given, R value you know, T1 value is given, T2 value is given. And what is the problem? Just to put the value, get the result. Only up to that you have to do calculation, simplification with precaution. Okay. Then after putting all the things, means log K1 value is given, log K1 is equal to 1.60 into 10 to the power minus 5. Okay. Plus log K2 you want to calculate, then log minus log K1 you can bring to the right side. It will come plus log K1. Then log K1 is equal to log K1, K is equal to 1.60 into 10 to the power minus 5 plus EA value is given. EA value you can calculate in kilojoule, it is given. You can convert it into only joule. Then you have to multiply by 1000 because it is given in kilojoule. Then now it will come 209 kilojoule is there. Then you can write 209 and 000 you can write. Now it became in joule per mole divided by now 2.303, R value is 8.314 joule per mole, because the R value is in joule, that's why you have converted into joule. Okay. And joule per Kelvin per mole R value. And then after that T1 T2 value are knowing, that is in bracket 1 upon 600 K 1 upon T1 minus 1 upon T2, and T2 value is minus 1 upon 700. Then all values just you simplify it, and then you will get the value of log K2. Then log K2 finally you will get, after doing all the things, after solving you will get, after simplification you will get minus 2.197. This is the value of log K2. Then now log K2 you can convert into the K2. Then log K2 is equal to minus 2.197. Then what is the value of K2? Easily you can calculate, correct? Anti-log you have to take. Then by the chart easily you can know. Then K2 is equal to 6.36 into 10 to the power minus 3 per second. Then here actually this anti-log chart will be given to you. If not, then directly they will give the value. Okay, they will give the value. Then like this way you can solve the numericals. Now I am going to discuss next factor, that is the effect of catalyst on rate of reaction. Last class I have discussed rate of effect of temperature on rate of reaction, and numericals also I discussed now. Now I am going to discuss effect of catalyst. Question is asked. Then what is the role of actually catalyst, that you have to understand. Then first you should know what is the catalyst. A catalyst is a substance which increases the rate of reaction without itself undergoing any permanent chemical change. Catalyst does not take part in the chemical reaction, you remember, but by its presence reaction takes place. Okay, and also you should know that catalyst may be positive or negative. Okay, sometimes it can increase the rate of reaction, sometimes it can decrease the rate of reaction also. Sometimes autocatalyst means during the reaction some product will form and that product will behave as a catalyst. That is called autocatalyst. You have to not add any catalyst from outside. Then here one example I am telling you, that potassium chlorate KClO3, if you will heat, then it will give you two products, potassium chloride and oxygen gas. Potassium chlorate on a strong heating around 1100 degrees centigrade, then it will decompose and it will give 2 KCl plus 3O2. But if you will heat it in the presence of less quantity of manganese dioxide, MnO2, this MnO2 will function as a catalyst. Then this reaction will take place at low temperature, where 1100, now it may take place at around 350 degrees centigrade. This reaction takes place, and where 1100, where 350. Then this happened due to presence of MnO2. Then here you should understand why does it happen. What is the role of catalyst, that you have to understand. Okay. Actually, one more thing you should know, the word catalyst should not be used when the added substance reduces the rate of reaction. Oxidation means loss of electron and reduction means gain of electron. Correct? Then it substance can oxidize, means it will absorb the electron, it will take the electron. Then other substance will lose and it will take. And substance which is taking the electron, that is called oxidizing agent, because for the oxidation this substance is responsible, hence it is called oxidizing agent. And suppose A lost the electron and B has taken the electron, then B is oxidizing agent. Correct? And who oxidizes? A oxidized. It has lost the electron and B has taken. Just reverse case, that that who gives the electron, or donates the electron, that is the reducing agent. Correct? Because now B is taking the electron, then B is going to reduced. Then for this reduction process, who is responsible? Then A is responsible. For the reduction process, A is responsible. It has given the electron to B. B has taken and it reduced itself. Then here A is functioning as a reducing agent. A is functioning as a reducing agent and B is functioning as a oxidizing agent. Then here what I want to tell you, that substance which you are adding, that should not reduce, okay, that should not reduce the rate of reaction. Or catalyst actually is used in a small quantity, not in more quantity. The substance is then called inhibitor if you will take in a more quantity. When the added substance reduces the rate of reaction, then that time the substance is then called inhibitor. It will slow down the reaction. Negative catalyst, its role is that it can inhibit. According to this theory, a catalyst, actually a theory name is intermediate complex theory. Intermediate explanation to understand this process, that theory name is intermediate complex theory. According to this theory, a catalyst participates in the chemical reaction by forming temporary bonds with the reactants, resulting in an intermediate complex. This has a transitory existence and decomposes to yield products and the catalyst. Here two things you have to understand very clearly. That as for example, A and B both are reacting. Then you know that all gaseous molecules or any other this also substance, okay, particularly gaseous molecules you will understand better, all will be in motion. Then they should come in contact. Only then reaction will take place. They can exchange the energy when both will touch to each other. Then any reaction I am talking, whether as you can say liquid reaction or solid, whatever be, or gaseous. Solid generally reaction will not take place. For the reaction to take place, it should be either in motion. Molecule must be in motion. Then maybe when it is in liquid, that time it will in motion and will move here and there. And if when it is in gaseous state, that time also it will be in motion. Then both actually molecules should come in contact to each other. Then they require one platform. Okay, one platform they require. Then here role of catalyst comes. Then catalyst, I told you generally it should be in powdered form, finely divided. Finely divided means very powdered form. Then molecules, it gives platform to stay there, to stay. Atom A and atom B both will stay there, and by that time they will exchange the, you can say, energy. They will exchange the energy, or you can tell electron exchange also is possible. Electron exchange. Then that time if suppose A is losing the electron, B is taking the electron, exchange of electron, you can tell transformation of electron. Then A will become positive charge, B will become negative charge. Then in short period, this happens. Okay, then charge will develop. Charge will develop on both A and B. Then one bond will be formed, because A will be negative charge, A will be positive charge. Suppose it lost the electron, the positive charge, B has taken the electron, the negative charge. Then here now they will make a bond, Then in the beginning A has made a bond with a catalyst. A has made a bond, weak bond with catalyst. B also made a bond, weak bond with a catalyst, a small weak bond. And when A and B they themselves reacted, then what will happen? Now both, as soon as this A and B will make the bond, then bond with catalyst will be broken. That bond will break and catalyst will be liberated and new product will be formed. Okay, then like this way, here after the formation of product, now there will be no role of catalyst. Then here actually on catalyst all things happens. Okay, then here transitory existence, I told you this complex law, intermediate complex theory, here this has a transitory existence and decomposes to yield products and the catalyst. Okay, just like activated complex theory, correct? Same things are here. Then now I have told you by graph also you can understand. Okay, graph is also, that is the graph is a between you can say this reaction coordinate versus product, reaction coordinate versus product. Then here y axis product energy, you can tell product energy, and this x axis reaction coordinate. Then here actually by graph you can understand these things also. Without catalyst its activation energy is more, means from reactant side it has to cross the energy barrier, and then after that it will give the product. Then to reach the energy barrier it requires more energy. Then here one graph or plot will be like that way. From the reactant side, after getting the energy it will reach to the top peak, and then that peak actually is the activated complex, you can tell, or transitory transition state, you can tell. And there only all things, the new formation of new bond, breaking of old bond, all things happen in transition state, and it will come down. Then before coming down it will generally it will release energy. Then sometimes it may release more energy, sometimes it may release less energy, but it will release energy. Then if suppose reactant is you can say from the reactant, when it is giving product after reaction, then sometimes energy will be more than reactant, and sometimes energy will be less than reactant. Then more than reactant means it will release less energy it will release. Okay, in comparison to the transition state, it will release some energy, because transition state means more energy. transition state means more energy, then it will come down because it is forming the product. But if product has more energy than reactant, then its energy will be more than reactant. Then that time, because it is more than reactant, that's why it will absorb energy. Finally it will absorb energy. That is the it is endothermic. And if product forms at low energy, lower than reactant, then it will release some energy. That is the, because it is less than reactant, then reactant less than reactant. How much less than reactant? That amount it will release. That is called exothermic. Then now this I told in a normal way it happens. Last class also I discussed. But if you will add MnO2 or any catalyst, then it will change the path of the reaction. Means now in the beginning more activation energy was required. Some energy reactant have, forget that things. But more what energy they have, reactant, more than that they require to come up to the transition state. Then that energy means activation energy, now it is more. But when you will add catalyst, then now this path will change. In presence of catalyst, new path, reaction will follow new path. And now peak will be lower than the, means in presence of catalyst peak will be lower, and in absence of catalyst peak will be high. Then lower peak means requirement of activation energy is less energy is required. Now activation energy became less. That's why reaction will take place easily, because activation, now requirement of activation energy is less, decreased in presence of catalyst. That's why reaction will go fast. Then in presence of catalyst, reaction change the path. Okay, and energy of activation with catalyst is now less, but in the absence of catalyst, energy of activation will be more. Okay, by the graph you can understand. Actually this is called effect of catalyst on activation energy. You can show it by graph, two graph. Second graph means presence of catalyst, you can show by dot. And dark line graph, that is in without catalyst, you can draw in dark line, and with catalyst you can draw in a dot. Okay, just to differentiate. Then now this I have discussed. It is believed that the catalyst provides an alternate pathway or reaction mechanism by reducing the activation energy between reactant and products, and helps lowering the potential energy barrier. Understood? That here catalyst provides an alternate path. Alternate path is also called reaction mechanism. By reducing means by they will decrease the activation energy between reactants and products, and hence lowering the potential energy barrier. Means quickly it can give the product. It is clear from Arrhenius equation that lower the value of activation energy, faster will be the rate of reaction. Okay, this you understand by the Arrhenius equation, that lower the value of activation energy means quickly. Now transition state is low, just like you are jumping 5-6 feet. In the beginning, suppose you were wanted to jump 6 feet, but now you have to jump 4 feet or 3 feet in presence of catalyst. Then see, Same situation is here. In presence of catalyst, now you have to jump only 3 feet. Means to get the product, now reactant has require less energy. Activation energy is required. But in absence of catalyst, it has to require jump more. Then for that more potential energy is required. This I have told you. Then Arrhenius equation tells same things. According to Arrhenius equation, lower the value of activation energy, faster will be the rate of reaction. A small amount of catalyst can catalyze a large amount of reactants because it is in a powdered form. Okay, actually what happens that you can understand like this also, catalyst role. If catalyst is not there, then you know that all these molecules or atoms will be in motion freely here and there. But when catalyst will be there, then it will be attracted by catalyst. It will be attracted by catalyst atoms. They will come there, they will stay atoms, and then they will just combine to each other. It will combine to each other. Okay, and after making between them that big bond which made or big force which they have made with catalyst, that is because that is a very big force for both reactants. Suppose two reactants were there, A and B, then that force will be, because that is a weak force or weak bond, then when they will make their strong bond A and B, then this bond will be broken. Okay, then this actually attracts A and B. They will come and they will stay on this surface of catalyst. That's why it must be in a powdered form. It should be a spread. Then it will all, you can say, atoms will come there. What they were moving here and there, now they will come on that platform. That's why reaction will take place easily, because their exchange of energy will be there. Low, it will decrease. But now that time they were required more energy. But now due to this, you can say platform of catalyst, it will require less energy because it has not go up. Then this I have told you that here quantity of catalyst is requirement is less. A small amount of catalyst can catalyze a large amount of reactants. A catalyst does not alter Gibbs free energy delta G. Actually, for the reaction to take place, delta G value is negative. It is not going to do anything. A catalyst does not alter Gibbs energy of a reaction, means delta G must be negative. Then it is not going to affect, it is not going to change the Gibbs energy. It catalyzes the spontaneous reaction. It catalyzes the spontaneous reaction, but does not catalyze non-spontaneous reaction. This is again very good question. Question is asked that this catalyst you can use only for spontaneous, which for that reaction it can increase, but not for non-spontaneous. Okay, this question is asked. It is catalyst can catalyze only a spontaneous reaction. It is also found that a catalyst does not change the equilibrium constant. It will not change the equilibrium constant of a reaction. Okay, it does not change the equilibrium constant of a reaction, neither from reactant to product, neither from product to reactant. It helps in attaining the equilibrium faster. Only that it will do that equilibrium will come easily. Equilibrium position they will attain faster. That is, it catalyzes the forward as well as backward reaction to the same extent. Both means product to reactant, reactant to product, both side. It will not take side of anybody. Equally, forward and backward reaction it will catalyze in the same extent. That's why equilibrium it will get easily. Equilibrium can be attained easily. Okay. Then here this important things I have told you, that a catalyst does not change the equilibrium constant. Equilibrium constant will be same, value will be the same. Equilibrium constant of a reaction. Okay. It helps only in attaining the equilibrium faster. That is, it catalyzes the forward as well as the backward reaction to the same extent, so that the equilibrium state remains the same but is reached earlier. Okay, this I have told you about this effect of catalyst. Effect of catalyst. Dog is working. Then this I have discussed effect of catalyst. Now I am going to discuss collision theory of chemical reaction. Collision theory of chemical reaction. Here actually three things you have to understand. Collision theory. Then many things now already you have understood. Activated complex theory you have understood. Means at transition state what happens, that now you are knowing about the formation of intermediate state. Now you have to know little more. Okay, according to this theory, collision theory, actually this theory was given by Lewis in 1916 to 1918. Between that this theory was given. It provides a greater insight into the energetic and mechanistic aspect of reactions. It is based on kinetic theory of gases. According to this theory, just remember 3 points I will tell you, main things, 3 points. According to this theory, the reaction molecules are assumed to be hard sphere. Okay, according to Lewis I am talking about, according to Lewis theory, the reactant molecules are assumed to be hard sphere, and reaction is postulated to occur when molecules collide with each other. The number of collision per second per unit volume of the reaction mixture is known as collision frequency. What is the collision frequency? Just you understand. The number of collisions means striking to each other. Molecules will strike to each other. Sometimes it will strike on the wall of container also. The number of collisions per second per unit volume of the reaction, mixture, actually you can tell reaction mixture, is known as the collision frequency, that is denoted by Z. How many in 1 second per unit volume, how much collision is going on, that is called collision frequency, Z, capital Z. Another factor which affect the rate of chemical reaction is activation energy. Okay, already you know, means A plus B, you know that A plus B gives the product. Then for this reaction, means A plus B is giving the product. Then for this reaction, rate of reaction, now new things in this reaction, you know that rate is equal to E minus EA upon RT, that you are knowing, where here you are introducing new term Z. Here you are introducing new term Z. Okay, then this actually A term you have already introduced, one capital A, frequency factor. Now here you are using a new term Z, where Z represents collision frequency. That was the collision factor. Just try to understand. A was there, that was the collision factor. Okay, but here Z is collision frequency. A is here collision frequency. Okay, that frequency factor, and also actually A was called Arrhenius factor. Arrhenius factor, three term was there for A. Arrhenius factor, second term was frequency factor, and also pre-exponential factor. But here you are talking about new factor. That is called frequency. Okay, then here Z represents the collision frequency. Here using the term collision frequency. Okay, then now actually that A will come under this Z, you remember. Okay, because now Z is talking about other things, I will tell you now. Then where here you are writing Z is equal to ZAB, means AB, Z and down you can write capital Z, AB means A and B is colliding, correct. Then ZAB, where ZAB represents the collision frequency of reactants A and B, and E, that is exponential power minus E upon RT, represent the fraction of molecules with energy equal to or greater than EA. Because you require this reaction requires EA, then this factor, my E exponential power EA upon RT, that tells about the energy, activation energy. It is telling about the energy either equal to activation energy or more than EA. Okay, then here if you will now correlate, if this relation means Z now rate is equal to Z into exponential power minus E upon RT, and another reaction was there, that is the rate is equal to A, capital A into E power RA minus KT, power RA divided by KT. If you equate both, then you will think that now A and Z have similarity. Okay, then here after comparison with Arrhenius equation, we can say that A is related to collision frequency, means Z. Equation, now what you got now, new equation that predict the value of rate constant fairly according for the, or can say accurately for the reaction that involved atomic species or atomic molecules, but for complex molecules. Here the term complex is coming. Here that this equation, new equation Z I am talking about, then here that this predicts the value of the rate constant fairly accurately. It will tell accurate value for the reaction that involve atomic species or simple molecules, but for complex molecules significant, you can say, deviations are observed. Okay, now for complex, this is what we are knowing, that is only for ordinary molecules, atomic form, or simple molecules are there, then it is for simple molecules, but for complex molecules significant deviations are observed. The reason can be or could be that all collisions do not lead to the formation of product. Here very important, one should not think that molecules are colliding to itself. Then actually to cross the energy barrier, molecules has to collide, that is a compulsory. Then during the collisions energy will be exchanged, then energy may increase, then it will cross that barrier and it will give the product. But simply collision, you can't tell that molecules are colliding that then it will give the product. No. Just like suppose in any competition like engineering and medical, any competition, 10 lakh students are appearing. Then all will prepare for examination, almost all, but all will not qualify. Only those will qualify whose preparation was too much, correct, means sufficient, optimum level, only they will qualify, other will not qualify. Like same things, collisions all will collide here before the reaction before giving the product, but all will be not successful collisions. Then only successful collision will give the product. Quantity of product depends upon the successful collisions, not like that how many molecules are taking part. Okay, they are taking part just like 10 lakh students, but who are qualifying? Only those students whose preparation is too much, optimum level, highest level. Then like that way here, that successful collision and unsuccessful collision. Then successful collision will give the product, unsuccessful it will not give the product. Then here we are talking about successful collision, particularly in complex molecules. Okay. Then here I am telling you that for the in case of complex molecules, the reaction could not be that all collision, the reaction could be that of all collision, and so all collision do not lead to the formation of products. The collision in which molecules collide with sufficient kinetic energy called threshold energy, means total energy. If you can say total energy, if they are getting what is required, threshold energy, total energy, if they will get, only then it will energy barrier it will cross and it will give the product. Then it will give the product. And now a second things, proper orientation is also required. Not only sufficient kinetic energy. All student will do hard work, but some student will prepare nicely, a special technique they will apply. Then that technique sometimes works. Then here some along with the hard work technique is required in a shortcut method. That is also required. Then here means a hard work in a proper manner. You can tell like this, hard work in a proper manner. Then here also collision should be required. Collision is required, but in a orientation of the molecules is also important. Orientation meaning I am telling you, suppose because here it is for complex molecules. In transition state many molecules will be there, many atoms will be there. Then suppose all have to collide to, suppose A atom with atom A, suppose 5 other atoms are there, all have to collide with you can say A, only then reaction it will give the product. Then suppose from the front side, front is not back end, already 3 atoms are there, 4th atom is outside, they can't touch the, even they can't see the A, then how it will react with that atom? No. Then suppose from the back side of the atom, now some scope is there to touch. Then if other atom will touch from the back side, then it can touch, it can come in contact with the A, then reaction may take place. Then this is called proper orientation. because from the front side it can't attack. Already one bond is there, old bond. Then where bond is not there, from that side it can attack. Then here orientation means it is talking about the direction or angles, from which side it is going to attack, from the left side, right side, north side, south side, front side, back side, from which side it is going to attack. Means it will attack and it will make a bond. That is very, very important. Then collision is important, and successful collision will be that only whose orientation is in a proper way. Hence these two terms now you are considering here in case of complex molecules. That along with the kinetic energy, what is required? Proper orientation, so as to facilitate breaking of bonds between reacting species and formation of new bond to form products. Okay, and this is called as effective collision. This is called effective collision. One is collision, it is effective collision. Old bond will break, new bond will form. Correct? Then this is called actually effective collision. Okay, then now you have understood meaning of effective collision. Then this effective collision is necessary. For example, for formation of methanol. This example I am giving you. Formation of methanol from bromoethane. Bromoethane depends upon the orientation of reactant molecules. Okay, the proper orientation of reactant molecules lead to the bond formation, whereas improper orientation makes them simply bounce back because it is not clear. Just like it will go and it will come back. It will come back because they can't, you can say they can't break the bond because already bond is there, a strong bond. They can't make a new bond. Then it can proper is there is no proper orientation. Then proper orientation of reactant molecules lead to bond formation, whereas improper orientation make them simply bounce back and no products are formed. To account for the effective collision, another factor P called probability or steric factor is introduced. Then second point is total 3 points I told you. Then simply when A was there, Arrhenius factor, that was the first things. Second things I told you Z. Okay. Now for the proper orientation, one term is used, P. One term is used because in effective collision both are required, collision plus orientation. Then now for the orientation one new term is introduced, that is called that you can say a term, that new term that is called P. P actually can denote by P called actually this term P is introduced, that is called P means probability or steric factor. Okay, new term is introduced to account for this effective collision. Another factor P called a P term is introduced. It takes into account for what? The fact that in a collision molecules must be in a proper orientation. Then this P is actually called probability factor or steric factor. Then now rate reaction, now you can write final rate equation, you can write, then rate is equal to P into Z, AB down you can write just near the Z, AB. A means A and B molecules. Then P and Z, two terms are there, P into P and Z, P into Z, and after that things are same, E exponential E upon RT. Before this term, exponential term, two terms are coming, P and Z. Thus in collision theory, activation energy and proper orientation of the molecules together determine the, or you can say both I am talking about, that in collision theory activation energy and proper orientation of the molecules together determine the, you can say, criteria for an effective collision and hence the rate of a chemical reaction. Then now what I told in the beginning, A term was there, Arrhenius factor. Now that Arrhenius A factor means these two terms, P and Z. Okay, then this is actually a final equation. Thus in collision theory, activation energy and proper orientation of the molecules together determine the criteria of an effective collisions and hence the rate of a chemical reaction. Okay, collision theory also has a certain actually drawback, as it consider atoms or molecules to be hard sphere and ignores their structure aspect. This actually one drawback is also there, because atom and molecules in this theory, collision theory, for complex molecules it is considered that atoms are hard, molecules are hard, but they are not considering their correct structure. All atoms are not a sphere and hard only. All atom or molecules are not hard and a sphere. They have their own structure. Then they have not considered all this, their structures, hence some drawback is there. Therefore all these things, for the special structure of the molecules or atoms, now another again some theory is there, but now at your level, at this level, you have to not study, that is studied at higher level. Okay, means for those who are doing MSc or preparing for CSIR NET, means for higher knowledge, higher classes, they have to understand all the things. Now I am stopping only here, and now entire this chapter now means chemical kinetics, it is finished. Next class I will start new chapter. Thank you.